Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en ik zit weer een keer met...
Nou, weer een keer. Altijd zit je met mij, Ronald.
Het voelt zo lang geleden.
Ja, nou ja. Jan Stomporst bij de weg. We zitten hier op TechX.
Ja.
Een geweldig event. We waren hier vorig jaar ook. En vorig jaar hadden we een hele kleine cubicle. En dit keer hebben we een gigantische stand.
Ja, want wij zitten bij ACC, ICT natuurlijk. Het bedrijf waar wij voor werken. En dan de sponsor al 3 jaar lang van de podcast.
Zeker.
Dus, we zitten hier eigenlijk hartstikke prima.
We zitten hartstikke prima. Dus...
And, of course, we have found someone on the floor to join us in the podcast. And that's Chris Noon van Alkira.
Hi, nice to meet you guys. Thanks for having me.
Yeah, great to have you. And Chris, can you please introduce yourself to our listeners?
Yeah, sure. So my name's Chris Noon. I am the Technical Solution Director for Alkira in the international region, which is anything outside the USA.
Okay. And how did you get started in the IT? What's your background?
Traditionally, I started working in ISPs. So I worked in some small ISPs in a place called Gibraltar, where I grew up. I've worked for a number of other organizations, both private, vendors, consultancy, all of those kind of things. I floated around a little bit.
And IT was always a passion of yours, or?
Yeah, I was always quite a geeky kid, always playing with computers and stuff like that. So I kind of fell into networking, and it seemed to fit with the way my brain works. So I kind of fell in love and continued to do networking.
Cool.
What is the thing that fits you in networking then? What's the most fun thing?
I think the one thing I really love about networking, and to be honest, is most IT-related fields, is everything is logical, right? Because it's only ever machine-made and kind of machines being put together. So the logic behind it and everything is a puzzle, and there's always a solution, and I love trying to find those solutions.
And there is always solution.
There's always a solution.
That's a good thing.
So you also has a background in with VMware and NSX?
Yes, yeah. I spent a lot of my time doing traditional telco stuff, so I worked with Cisco's, Junipers, FortiGates, F5s, those kind of things. I then moved into, I worked for an online gaming company called Entain, Ladbrokes Coral originally. That's when I learned about NSX, and then I was like, oh, this is really good. This is going to be the next big thing. So I actually applied for a job and then started working with VMware, and then kind of left and just carried on doing software-defined networking before moving to the cloud.
Yeah, because Alkira, the company you work for, can you tell us what they do?
Yeah, we have a pretty unique proposition. So typically back in the day when people wanted to connect things up for on-prem, you're looking at co-location providers or ISPs trying to plumb everything together. Now you're looking at clouds. How do you plumb them together? Do you route them through data centers? Do you have a mesh of IPsec VPNs? Those kind of things. Where Alkira is this kind of orchestrator that can now sit in the middle. We're built on the cloud for the cloud. So we build in AWS, Azure, and GCP. So we're virtualized co-location facilities and virtualized POPs. And we can connect on-prem and all the major clouds together, which is quite unique.
Okay. How does that work?
So in essence, what we do is, let's say you are primarily AWS users, but you have a sprinkle of Azure and you have a sprinkle of GCP and OCI, right?
Yeah.
So we go, okay, fine. We're going to build you virtualized POPs within the AWS. So we would spin them up in Virginia, London, Frankfurt, and Singapore, for example. We spin them up. Everything's stood up as a service, completely as a service, nothing for you to do. And then if you had some data centers, you can connect them into the London prop, into the Virginia prop via IPsec, ExpressRoute, Direct Connect, SD-WAN, whatever you like. So your physical components are connecting into your local virtualized POPs. And then under the hood, we use a lot of cloud-native constructs. So we pair with VPCs in AWS using VPC peerings. We use VNet peerings for Azure, and we use things like cloud routers for Google Cloud and stuff like that.
Yep.
So what we're trying to do is just orchestrate a lot of the networking pain away because it's different in every cloud. And then in essence, we become the centralized hub. So all of our nodes then start forwarding your traffic across the globe.
Okay. Awesome.
But you also have experience with Kubernetes.
I do have a little bit of experience with Kubernetes. I worked for an automation company called M0, and a lot of what we did there was Kubernetes backed.
Yeah, but also Kubernetes also has networking. Is that something you have looked into, or?
Yeah. I've got a couple of friends that actually work for Isovalent that created Cilium. They've obviously been acquired by Cisco, so I spent a little bit of time trying to understand Kubernetes networking, and so it's another beast that you have to get your hands on.
Another beast, and could you elaborate on that?
Yeah, I think throughout my career, whether I worked at telcos, SDN, cloud, or I'm looking at Kubernetes, the same constructs are all there. There's just a variety of flavors, right? So it's still layer 2, it's still layer 3. There are communications, there's encapsulation, there's security, all of those different pieces come together. They're all done in a bunch of different ways. And a lot of the challenging is learning the acronyms and the specific ways that things are pun together in all these different environments.
Mm-hmm. Is eBPF not a different thing?
Yeah, and then eBPF, the way they deliver it, so it's almost like networking at the kernel level. So there's a lot of the raw functionality and the logic. As network engineers, we always work in the OSI model, like 1, 2, 3, 4, and it becomes physical data and that kind of stuff. But yeah, because it's done there, you have to understand what it's actually doing from an eBPF level, which was fascinating when I was learning it.
Yeah, but I imagine you also do zero trust environments and stuff. Is it something you also see if you want to build a zero trust environment? What was the baseline you would use there? Maybe specifically, if you look at I don't know if you're familiar with if you look at Kubernetes and you want to build a zero trust networking around that, do you have what should we look for as a baseline?
Yeah, so I mean, from an Alkira perspective, we kind of sit at the edge of the VPCs and the VNets, so we don't actually touch into the Kubernetes networking and ZTNA piece. We are developing agents for ZTNA and Zero Trust, but typically we would work with some of our partners that do that. So we don't currently do that, but with most Zero Trust, it's all about identifying the application or the users and then providing them with least privilege, whether that be through layer 4 policy, layer 7 policy, and some kind of inspection.
Okay. So you're also familiar with the ingress, I assume, and the egress maybe also?
Yeah.
How do you see that they don't become the weakest link in the whole configuration?
Yeah, I think some of it has to do with obviously the guardrails that you put up on what you allow people to do. It's the same in cloud. It's the same in Kubernetes. It's the same with on-prem. Traditionally, it's
always.
It's how much privilege you give. How much privilege you give these users. I see obviously with Kubernetes, it's a lot easier to automate these things through things like Terraform or Python or whatever it is you want to use to automate. And as long as you have some kind of CI/CD pipelining tool set that has authorization and processes around that, I think that's usually the easiest way to secure it. Otherwise, it's a kind of a... So I'm trying to think of the Wild West out there.
Yeah. So, can you give us an example from Alkira, like a use case or a problem that you guys have solved for a company? You don't need to have the name of the company, but like a specific use case that they will come to you.
A fun story.
Do
you have a fun story for us?
We've got tons of different companies around the globe. We've got some very interesting ones. So we have one that has sovereignty requirements for its data and security. Mm-hmm. So every piece of data that transfers from one VPC to another VPC or one VNet to another VNet has to traverse a layer 7 firewall, and it has to have IDS and IPS inspection. So they only have data centers in one region, and then they ended up having 3 regions globally, very far spread apart. So what they ended up doing was hairpinning everything from, let's say, London to Singapore and back between 2 VPCs. And then they were like, okay, we're going to start needing to build these things out in cloud. If you've ever tried building layer 7 firewalls in cloud, it can be complex. You need experts in multiple clouds.
Yeah.
So what Alkira does is we deploy our CXPs as close as possible to those customers, and we allow service insertion with next-gen firewalls. So we do Cisco, Checkpoint, Palo Alto, and FortiGate. They chose Palo Alto, and now they are essentially in a neighboring VNet or a neighboring VPC to what they have deployed within their applications. So now a VPC in London talking to a VNet in London runs through our CXP, and obviously it's a very skewed stat, but I think we took the latency down from 130...
That was my follow-up question, yeah.
Yeah, the latency's gone down from 135 milliseconds to, I think, 6.
Oh, that's impressive. Yeah.
And it's just the way we've built... They could have kind of done something similar, but it takes a lot of effort and a lot of complexity and understanding. And in a single cloud, it can be done. It's when they start rolling out to multiple clouds, and they're now looking at GCP. So that would have been another cloud they would have had to design security around.
Are you? You said you have a POP and in that cloud.
Yeah.
So you're also doing the transit of the traffic.
Yeah. So we almost become like, if it was VPC to VPC, you can think of Alkira as a transit gateway. And if you were to do AWS to Azure, you could see us as some kind of transit gateway IPsec to a vHub.
And do you have your own lines between the...
We have no hardware whatsoever.
Okay.
We are built completely in the cloud, so much like everybody else, we deploy in VPCs, we deploy in VNets, and then we peer with cross-account peerings.
And does the customer need to pay their egress-ingress traffic?
So something we can never escape is when you leave AWS or whether you leave Azure. So if we use as AWS, for example, you're always going to pay 2 cents when you leave, whether you leave to us or whether you leave to something else. That's at a bare minimum, and then it kind of scales up depending on how many nodes you go through. So it's always 2 cents to us. And then we have a flat egress cost, which we provide all our customers, but we also have that traditional model. We call it an enterprise level agreement. You'll be surprised how many companies you go to that really don't like networking as an OpEx model. They are very traditional in that sense.
I can imagine, yeah.
Yeah, and sometimes it's a little hard to push through. So we have an enterprise level agreement where you pay a slight premium on our service, but it's completely unlimited data egress.
Okay.
Which can be dangerous, obviously.
Yeah.
Okay, but what was like a fun story where you guys like learned the most of? You know, it's always fun to hear like the stories like where everything works, and but there are also like probably situations where things were like the learning moment.
I think one of the more recent ones is DORA compliance within the within the EU.
Of course.
So it's everywhere. I mean, I think I read iSurveillance recent paper on DORA compliance as well. So they have some best practices around that. So when we were working with financials mainly, obviously, we have designs, we have standard blueprints that we kind of recommend and deploy, but there are certain elements to DORA where you start having to do some unique designs, and we have flavors of design depending on where they want their data traversing, where they want their data decrypted, expected, and re-encrypted. So we have all these different models now for financials, and it's very much how much buy-in do you have with Alkira? Do you want to do it in a phased approach? And we can do phased approach with financials and stuff like that. So that was a tremendous one. We actually have, instead of doing the firewall inspection within Alkira, they're like, no, it needs to be in an account that's owned by us. So we do everything, all the routing, all the plumbing of all the clouds together. But the next-gen firewall sits in their account, and then we do some weird like looping back round through like a security VRF essentially. And then we end up doing the inspection and coming back, and they're happy because it technically is in their account. Yeah. So there's some unique elements to that, and that took way longer than we wanted to design, but happy customers.
That's the thing we do. Yeah, exactly. Yeah. So you built like a network as a service, right? Mostly for companies, right? If they have like a multi-cloud setup or like a public cloud, a private cloud, or on-premise stuff, you can bundle that all together in one big network, right?
Exactly.
To make it flat. I can also see a way that you go one step higher in the tree is that you see like they're always talking about like one unified European cloud, and you have like different cloud providers and connect them in like a multi-cloud solution. That we have heard stories of companies that are looking into. I have my cloud provider, or it's like in Germany with company X. But if something happens with that cloud, I want to move all my stuff to like a data center or in a cloud in the Netherlands, for example. Is that also something you hear from your perspective or field that people are also looking at that not integrate like the company network, but like data centers in itself?
Yeah, so it's almost like having rather than just having resiliency in different regions, you're looking at cloud resiliency as well. So DORA compliance is pretty heavy on that as well, where it's like you have to be in a data center and a cloud or two clouds and stuff like that. We're seeing a lot of people almost want to split the workloads between two clouds or at least have a DR in another cloud. And that's something we do help with. So we can give like regional and cloud resiliency. And I think nowadays, I'm sure you're going to speak to lots of more people that are going to mention the word AI, so I won't spring it out too much today. But we're seeing those conversations crop up a lot more now. It's like they want to use the easy-to-consume AI-generated tools in cloud. AWS Bedrock is a very simple one to consume, but then they only want it using kind of enterprise data, nothing public. So that RAG model that everybody's talking about now, so it's easy for their employees to consume. So how do you connect your object storage that's on-prem into AWS, but then what if you want some kind of other modeling done in GCP because it needs better training or something like that? So how do you connect them all together? And that starts to become the conversation we're having now more and more.
Yeah, interesting.
That's right. Really interesting, yeah. Just thinking about it. And you were saying you've got POPs in different clouds, and you're securing that traffic between POPs also.
Yeah, so realistically what we love to do with customers is if you have a POP in Virginia and you have one in London, if I deploy both of them in AWS for you, we technically ride the AWS backbone.
Yeah.
Which means you get one of the if you classify them as the ISP, they are the largest ISP in the world. No one spends more money on them than networking. And then if you were to, obviously that would be over private channels. So you never leave that network, and it's completely encrypted from end to end. So it's completely isolated, completely privatized. If you were to start switching between the two, like having AWS CXPs, we call them CXPs, Cloud Exchange Points, and Azure CXPs, then there's an element of public internet. We ride some of the private piece, but there has to be that hop over. So we can do one of two things. One of the things we love to do is we automate it, but it's in essence IPsec between two CXPs at some point.
Yeah.
Or we can offer you private connectivity where we loop through a data center. Obviously, that runs up cost, which is why we try to avoid that, but some customers have deeper pockets than others.
Okay.
And do you see like a shift in like traffic or stuff when you look at the AI stuff? Is there something different in the networking part in the AI?
I think from the networking part, it depends what type of traffic, right? You obviously have the training piece and you have the inference piece. I think with the training, because there's just so much data, I think obviously to dumb down networking, we're shifting packets from A to B, and we're shifting packets from A to B. Depending on the type of work you're doing, is either just very high scale data, and even when you're doing the inference modeling, like you're always updating it, you're re-embedding things and updating the vector DB and stuff like that. There can be a lot of movement, but typically it's not as much. So it really depends when we have those customer discussions, how much are they doing? What are they doing? And it depends on the size of nodes we build. So our node size, obviously, accordingly, and we scale. But I think nothing's changed massively from a networking standpoint. It's just sheer data.
Just more.
Just more. It's like
but it's only more when you're training. Is it also more when you're using AI?
No, I think the training models is by far the most consumption of data. And obviously just probably depends on the usage when you're kind of just chatting with it or asking it to do some analytics. And it depends what type of stuff you're doing. If you're doing heavy analytics and you have a model that's analyzing a lot of data, financial trends or something like that, sometimes that can be quite heavy. We have a number of stock exchanges that we're talking to, or we've got them as customers. And then it's one of those things where they just have a lot of data coming through. Everything's done by the millisecond. They're looking at trends. If they're going to start looking at AI and pushing it through Alkira, then that's a lot of data coming through for a lot of markets.
Yeah, stock exchanges are always a lot of data.
Yeah, and they want super low latency and high latency and stuff.
Do you have customers? Because I've got a history in stock exchanges, and so I know a lot about that. But do you have traders as customers? Because better question: is your network faster than the normal way?
So if you're talking about
latency,
I'll be surprised if the internet ever beats us from point A to point B. It very rarely happens, if at all. From an MPLS standpoint, a couple of milliseconds up, a couple of milliseconds down. Sometimes I did a test recently with South Africa to Australia, and they were using MPLS, and we lowered it by something like 22 milliseconds. But we can be 10 milliseconds higher. It really depends on the routes that we take.
Yeah, of course.
But we're in and around there. And I always like to be an honest and candid kind of presenter. One of the things we do is we offer SLA uptimes, but we don't offer SLAs in latency. So that's one of the things we...
No, it's difficult.
Yeah, we do struggle with, just because we don't own the backbone per se. So we had a conversation recently with telecommunications, like a TV broadcasting service, and I said you're going to want an SLA on that latency, and we don't offer that, so we're not a good fit for you.
No, in my past, I talked to telcos, and I asked them, what is your latency? They didn't like that.
Yeah.
Because
then you're held to it.
Yeah, also, but I was comparing the lines between them on latency.
Yeah.
And they don't like that. But it was for a trading company, latency is the more...
It's key.
Yeah, it's key.
Yeah, I mean, I have a lot of friends who end up doing trading, and they always complain when there's a slight blip or a slight bit of latency. It can cost them hundreds of thousands, sometimes millions. So
yeah.
That is key.
Yeah,
So how do you monitor that, or observability?
Yeah, we have more monitoring than I care to go through internally. We have a very large support team spread across the globe, and they're constantly monitoring. And honestly, the amount of times there's like a tiny issue, we find it and resolve it before a customer has even realized what's happened, is almost all the time.
Like trend analysis, that kind of stuff, or something.
We have constant threat analysis. We have bounty programs. We're SOC 2 compliant. There's a pen testing constantly. There's tons that we do around that. But even from just the latency standpoint, to go to your thing, there's only so much we can do because of cloud backbones. But we are premium partners with all of the clouds, so we get premium support from those as well. Should an issue arise.
Awesome.
Okay. Yeah.
Time for a final question.
Yeah, go ahead.
And we always ask our final question, how do you see the future? And it's more, you're a networking guy. It's more about networking. How do you see the future about networking?
What would you like to see?
Would you like to see?
I think I work for Alkira, but I'm a bit of a fanboy as well. I liked them before I joined them. I love the way that you can have one single pane of glass and you can connect a number of things. But even from that standpoint, the architecture, obviously you're a Kubernetes kind of based podcast. I love the idea of microarchitecture. I love the idea that you can start breaking out all of these components, not only in applications, but a lot of people are starting to do that with networking as well. It doesn't need to be one massive monolithic box where one thing goes wrong and the whole service crashes. It's very much how we build our architecture. Everything is microservices, and if one thing breaks, it doesn't mean the whole machine breaks down. And I really like the way kind of networks are kind of taking on an application kind of build structure, because they're breaking out all of these little kind of functions rather than creating this one box.
Okay, cool.
Yeah. Well, Chris, thank you for joining us in our podcast, and we will look at the development of Alkira very closely and hope to talk to you again in the future.
Perfect. Thank you very much.
Okay.
Thank you very much. Yeah.